This missile should not be stoppable. It was moving faster than a rifle bullet. It could change direction mid-flight. Every defense expert said interception was nearly impossible, and yet it was destroyed. May 2023. Kyiv, Ukraine. A Russian Kinzhal missile streaks through the sky at Mach 10 over 7,600 miles per hour. Ukrainian patriots track it, fire, and for the first time in history, intercept a hypersonic missile. Here's what nobody told you. That interception was extraordinary, not routine. It required perfect conditions, advanced systems, and extraordinary timing. And what makes this terrifying is that most of them still haven't been stopped. Not by current defenses, not reliably. Three nations, Russia, China, and the United States, have weapons that travel so fast, maneuver so unpredictably, that conventional missile defense becomes nearly useless. You're about to understand why. Because hypersonic isn't just fast. It's a complete revolution in how wars will be fought. So what makes these missiles different from everything that came before? Every missile that reaches space is technically hypersonic. ICBMs hit Mach 20 during re-entry. Ballistic missiles have exceeded Mach 5 for decades. So why is everyone suddenly terrified? The difference is maneuverability. Traditional ballistic missiles follow predictable arcs: launch, climb, descend. Radars track their trajectory, calculate impact point, fire interceptors. Simple physics. Hypersonic weapons don't follow ballistic trajectories. They can travel and maneuver significantly during atmospheric flight at speeds above Mach 5, flying low enough to avoid early warning satellites, but fast enough to compress decision timelines 2 minutes. They come in two types. Hypersonic glide vehicles are boosted to high altitude by rockets, then glide back down while changing course unpredictably. Hypersonic cruise missiles use scramjet engines to sustain Mach 5+ speeds throughout their flight, powered continuously but exponentially faster than regular cruise missiles. Both share one terrifying characteristic: they can change course mid-flight, making interception almost impossible with current technology. But to understand why they're so dangerous, you need to know what happens when something travels at Mach 5. At Mach 5, you're moving over a mile every second. Think about that. In the time it takes you to blink, a hypersonic missile travels the length of 5 football fields. The engineering challenges are brutal. First, heat. At hypersonic speeds, air friction creates temperatures exceeding 3,000 degrees Celsius, hot enough to melt steel. Engineers solve this with ablative heat shields that burn away gradually, ceramic composites that withstand extreme temperatures, and thermal management systems that channel heat away from electronics. And every one of these systems exists for one reason: any of them fail, the missile dies. Second, control. At these speeds, tiny adjustments create massive course changes. Controlled surfaces must withstand temperatures that would vaporize conventional materials while providing precise maneuvering. The plasma sheath that forms around the missile ionizes the air, disrupting radio communications and GPS signals. Third, propulsion. Scramjets feed supersonic air directly into the engine, using shock waves to compress and ignite the air-fuel mixture. Unlike traditional engines that slow incoming air, scramjets compress supersonic airflow, mix it with fuel, and ignite it while the missile screams forward at Mach 6 or higher. The tolerances are insane. Millimeters matter. Microseconds matter. Everything must work perfectly while experiencing G-forces that would crush conventional aircraft. Only 3 nations have solved these problems, and that's what makes this so dangerous. Russia fielded operational hypersonic weapons first and used them in combat during the 2022 invasion of Ukraine. And every one of these weapons exposes the same weakness in modern defense. The Kinzhal, carried by MiG-31K fighters, reaches speeds up to Mach 10 with a 2,000-kilometer range. Russia used Kinzhals extensively against Ukrainian infrastructure. The Sirkin, a ship-launched hypersonic cruise missile, travels between Mach 6 and Mach 8 with approximately 625-mile range. Russia deployed Sirkin operationally in January 2023 and first launched it into Ukraine in February 2024. The avant-garde, mounted on IC, reportedly maneuvers unpredictably during re-entry, threatening U.S. homeland defense. China isn't just competing, it's leading. China has conducted 20 times as many hypersonic tests as the United States. The DF-17 combines a ballistic missile booster with a hypersonic glide vehicle exceeding Mach 5. In October 2025, China unveiled a morphing hypersonic missile prototype featuring retractable wings that allow it to dynamically adapt its shape mid-flight, minimizing drag during high-speed cruise and improving maneuverability when extended. This represents what researchers call the holy grail of hypersonic flight real-time shape adaptation at Mach 5. The United States trails in deployment. The AGM-183 ARRW was cancelled in 2023 after failed tests. Then revivet in 2025 as Air Force leadership cited the need to catch up. The Pentagon is developing the long-range hypersonic weapon for the Army and conventional prompt strike for the Navy. But having these weapons operational is different from being able to stop them, and that's where the real problem begins. Current missile defenses were designed to intercept ballistic missiles following predictable arcs. Hypersonic weapons break that entire system. First, detection. Most ground-based radars cannot detect hypersonic weapons until late in flight due to line-of-sight limitations because they fly low, often below 100 kilometers. Altitude ground radars can't see them until they're close. By then, there's minimal time to react. Space-based satellites designed to detect ballistic launches struggle with hypersonic threats. Former Undersecretary Mike Griffin noted that hypersonic targets are 10 to 20 times dimmer than what satellites normally track. Second, tracking. Even if detected hypersonic missiles maneuver unpredictably, traditional defenses calculate intercept points based on ballistic. If the target changes course mid-flight, those calculations become useless. The missile might head for one city, then shift toward another without warning. Third, interception speed. To catch something traveling Mach 10, your interceptor needs to be faster and more agile. Current interceptors aren't Patriots, DODs, e.g. Sol, designed for slower threats. Fourth, terminal phase vulnerability. Some analysts argue hypersonic missiles slow down for accuracy. Research shows that to avoid interception by Patriot PAC-3, hypersonic vehicles must maintain speeds above Mach 6 during terminal descent, requiring approximately Mach 10 at the start of the dive. They slow down slightly, but not enough for current defenses to reliably intercept. The May 2023 Kinzhal interception proves it's possible, but that required perfect conditions. That's not a defense system. That's exceptional performance under ideal circumstances. So what's being done to fix this massive gap? The United States is developing the glide phase interceptor specifically designed to kill hypersonic glide vehicles during their glide phase. Congress mandated initial operational capability by December 2029 and full capability by December 2032. And every year this slips. Offensive weapons get faster. The GPI will integrate with the Aegis system, fired from Navy destroyers. Northrop Grumman was selected in September 2024 to develop it. But there's a problem. The Pentagon requested less than $515 million for hypersonic defense in 2022 and 2023. Combined, compared to over $8 billion spent on offensive hypersonic weapons. Congress stepped in, authorizing $225 million in additional funding and mandating faster time. Initial operational capability by 2029 means at least 5 more years before a viable defense exists. The US is also developing space-based tracking. The Hypersonic and Ballistic Tracking Space Sensor will provide persistent surveillance from low Earth orbit, detecting threats earlier and providing targeting data to interceptors. The Space Development Agency's satellite constellation includes tracking layers specifically for hypersonic threats. Europe is pursuing twister timely warning and interception with space-based theater surveillance. Japan signed an agreement with the US in May 2024 to cooperatively develop directed energy weapons. High-powered lasers offer another potential solution, targeting missiles during boost phase when they're most vulnerable. But these remain experimental. The reality, defenses won't catch up to offensive capabilities for years, maybe a decade. Meanwhile, adversaries keep testing, refining, and deploying. So where does this lead? Within 5 years, expect China to deploy morphing missiles operationally, Russia to expand Sarkan across its fleet, and the United States to field long-range hypersonic weapons. All of this leads to one outcome: decision time measured in minutes. Costs will drop as production scales. Accuracy will improve as guidance matures. More nations will acquire them. North Korea has been testing since 2022, with India, France, Australia, and Japan developing programs. Within 10 years, expect AI-controlled hypersonic systems that predict defensive reactions and adjust trajectories autonomously. Reusable hypersonic aircraft for intelligence and strike missions. Pentagon tests in December 2024 and March 2025 demonstrated reusable hypersonic flight with the Talana drone reaching Mach 5. The strategic implications are profound. Nuclear-armed hypersonic missiles compress decision timelines 2 minutes, increasing miscalculation risks during crises. Conventional strikes could destroy high-value targets before defenders react. The nation achieving hypersonic superiority gains first strike advantage that could decide conflicts before they begin. But here's the uncomfortable truth. Hypersonic missiles have significant limitations. They generate bright infrared signatures visible to satellites. They're not invisible. The plasma sheath disrupting enemy communications also disrupts their own guidance. Extreme maneuverability requires precision systems that fail under combat stress. Scramjet engines are susceptible to disruption. Materials that withstand extreme heat are expensive and vulnerable to defects. But none of those limitations matter if defenses can't exploit them. And right now, they can't, not reliably. That's why the US is spending billions catching up. Why Congress mandated accelerated. Why allies are cooperating on development? Because in warfare, speed has always mattered. But hypersonic speed doesn't just compress time, it compresses options. Hypersonic missiles, explained simply, they're weapons that travel over a mile per second, maneuver unpredictably, defeat current defenses, and force military planners to rethink decades of strategic assumptions. They're not science fiction. They're operational, and they're changing warfare faster than defenses can adapt.